Okay. So what are you thinking? First, find 3 consecutive integers. So what should we do first? What am I doing here? What am I wanting to do? So my first variable is x. They're even integers. So my next one is x plus 2. And my last one is? So it says the sum of the first 2 integers. How do I show that? The sum of the first 2 integers. X plus 2 is equals 24 more than the third. X plus 4 plus 24, or you could put 24 plus x plus 4. Doesn't matter in the order for addition. Does that make sense how we came up with that equation? Okay, so let's combine like terms. Sailor, what do I get on the left side? When I combine like terms, x plus x is 2x plus 2, right? What about on the right side? What do I get on the right side, Jasmine?
1x plus 28.
Yeah, 1x plus 28. Miles, what do you want to do first?
Subtract the 2 on both sides.
Awesome. So 2x equals 1x plus 26. Last step, Tessa.
And then we'll subtract 1x from 2x.
So x equals 26. So x is our first integer. 28 is our next integer. And 30. How could you check this? If you wanted to check it to make sure you were not being crazy, how could you check this? Well, take the first 2 integers and add them together. What is 26 plus 28? It's 54. And is 54 equal to 30 plus 24? It is. Okay. I think these word problems are tough. All right. Now we're going to do some distance, rate, time problems. The first one I think is a really good question. The second one I think is a not so good question. We're going to do it anyway. But then I embedded a worksheet into Canvas, and we're going to do a couple of those problems on a separate sheet of paper. So let's talk about distance equals rate and time. So I just want to show you that if I, let's see, how do I want to do this? So distance is like, could be in feet, it could be in miles, it could be in kilometers, whatever. Time could be in seconds. Typically in questions like this, it's in hours. So the rate is like your miles per hour, right? MPH, or kilometers per hour. Okay, that's what that means. So we can find the distance, how far someone traveled, by taking their rate and multiplying it by their time. So if I'm traveling 55 miles for 4 hours, I'm going to travel a distance of 220 miles. That's kind of how that works. This is my rate. This is my time. Okay. So we're going to start with a couple of distance, rate, time problems. Again, I don't love the second one, but we'll do it anyway. So a cargo plane flew from the US across the Atlantic at 232 miles per hour. So this is my rate. 232 mph. So I always try to draw pictures because I love pictures. Please don't judge my drawing. I'm definitely not an artist. That's my airplane. It's flying this way at a rate of 232 miles per hour. But then it goes back. Do you see how it turns around and goes back? It goes back, and when it flies back, it's flying at what rate? What's the speed that it's flying at on its return trip? Yeah, 252 miles per hour. Probably had a headwind. Probably was getting pushed, right? So given that the first trip, this trip right here, took 2 hours, how long did the second trip take? We're trying to figure out the time for the second trip. So let's talk about the first trip. I know that the distance, the total distance that I traveled on my first trip equals my rate multiplied by my time. So can I figure out this distance right here if I know that my rate is 232 and my time is 2 hours? Yes or no? What is the distance? How do I solve that? Yeah, I'm just going to multiply. I'm going to take 232 and multiply it by 2, and that's 464. So this distance traveled is 464 miles. And it's the same distance that I traveled going to as coming back. The distance is the same. Does that make sense? It's like every morning I leave my house in Swansboro and it takes me 37 minutes to get here because I hit all that morning traffic. On the way home, I can make it home in 25 minutes because there's not as much traffic. No buses, no base traffic. Do you know what I'm saying? So I'm obviously driving faster on the way home than I do on the way to school, but I'm traveling the same distance. So that's what this is saying. On the way to their trip, they traveled slower. On the way back, they traveled faster, but the distance is still the same. So we're trying to figure out the time for the second trip. So let's write down what we know about the second trip. We know that the distance is 464. We know that the rate is 252. We don't know what the time is. So could we figure out the time? Because that's what the question is. Could we figure out the time on the second trip using the formula D equals RT? I hear crickets. I don't hear anyone saying anything. What do you think? Could we substitute some values for those variables? Naomi, what's D? What is it? It's distance. What did we say the distance on the second trip is? What is it? So the distance is 464. Do we have a rate for the second trip? What's the rate on the second trip? 252. We don't know the time, so we're going to leave that as the variable t. Okay, this is just an equation. You guys know how to solve this? How do I figure out how long the trip took? Divide both sides by 252. So 464 divided by 252 is 1.84. So that's 1 hour. That's where the whole number 1 comes in. How would I figure out how many 0.84 of an hour? Could I turn that into minutes? How? I can. How many minutes are in an hour? 60. So to turn that 0.84 into minutes, I take 0.84 times 60 to figure out how many minutes. So let's see, 0.84 times 60 is 50.4. So 1 hour and 50 minutes. So on the trip across the Atlantic, it took 2 hours. The trip back home only took an hour and 50 minutes. I was able to take 10 minutes off. Probably because, again, like I said, you had wind at your back. It was pushing you, right? Okay. All right. So I want you to think about this is the same distance because we're going someplace and we're turning back around and coming back home. So in this trip, Mary left for vacation. So I'm assuming that she's driving a car. Here's Mary's car. Throw some wheels on there. So this is Mary. And she left the city for vacation. That's all I know. Mary left the city for vacation. So Sarah left the city also for vacation, but she left 5 hours after Mary did. So Sarah is driving this schwanky car. So if this represents time, how much time has passed from here to here? 5 hours. Good job. Okay, because it says Sarah left 5 hours later. We'll come back to this in a second. After 4 hours, Sarah caught up. So how much time takes place here? After 4 hours. So after 4 hours, Sarah caught up. So she's also on vacation. So I think sometimes it makes sense to make a chart. I don't know if that works for you, but remember we're going to do distance, rate, and time. So what do we know about their distances? What do we know about their distances? They're the what? Yeah, their distances are the same. So I'm just going to use the variable d for right now. What do we know about the time? How long did Mary drive? Mary is the purple line. How long did Mary drive? Mary drove for 9 hours. How long did Sarah drive? For 4 hours. So there's our time. We know that Sarah was going 50 miles per hour faster than Mary. So if Mary's speed is R, then Sarah's speed is what? R plus 50. Good job. Okay, so we know that their distances are the same, right? So the distance of one equals the distance of the other. And remember that distance is rate times time. 9r has to be equal to 4 times the quantity r plus 50. So I just took from my table my rate and multiplied it by my time. So now we have an equation. We just need to do some distributing. So 9r equals 4r plus 4 times 50 is 200. Subtract 4r from both sides. 5r equals 200. Divide both sides by 5. So r equals 40. So Mary was putzing along at 40 miles per hour while Sarah was racing along at 90 miles per hour. So the question is, what was Mary's average speed? I mean, maybe she was driving a horse and buggy. I'm not really sure. Questions? What are your thoughts about that? Do you want to do another example of a problem like this? I think it would help. Well, we're gonna, anyway. So get out a piece of notebook paper and we're gonna staple it into your notes. Please and thank you. So I'm just going to add this right to our notes. So we're going to do problem number 1 and number 2. This is embedded into your module. I just want to give you a couple more examples. Because I feel like the more examples you have, the better you'll be at these problems. So remember, we're talking about distance equals the rate multiplied by the time. We're just going to do number 1 and number 2. So an aircraft carrier, so we got this big giant ship, water, maybe it's got a plane or two on it, I don't know. It's going to Guam, and then it's coming back. So this is the trip to and the trip back. So what do we know about the distance? If I go somewhere and I come back, what do we know about the distance? Same. Good job, Rosie. Sorry, Rose. Distance is equal. Are you guys okay with that statement? I just feel like that helps. The distance is going to be equal. So the trip there took 3 hours. And the trip back took 4 hours. It averaged 6 kilometers per hour, 6 km/h, on the return trip. So let's we can set up a table, but I'm just going to say the trip there and then the trip back. So what is the rate multiplied by the time for the trip there? And what is the rate multiplied by the time for the trip back? Well, hang on a second. Do we know the rate? We're trying to find the rate on the trip there. Do we know the rate on the trip there? Do we know how fast they were traveling on the way to Guam? No, that's just R. R times 3. What we know is on the trip back, this is the information for the trip back. We know that on the trip back, my rate was 6 kilometers per hour times 4 hours. So Rose told us that these two distances are what? The same. So that means I set these two equations equal to each other. So what is the average rate on the trip there? Eight kilometers per hour. So average speed is 8 kilometers per hour. I'm going to not do number 2 because I wrote all over that space. I'm just going to scroll down to number 3. So we're going to do one more practice. Again, these are in these notes are embedded into your module because I'm going to assign a couple of these problems for tonight probably. Okay, so a cattle train left Miami and traveled towards New York. So I went from Miami to, must be rearranging upstairs in Miss Curley's room, to New York. Okay. 14 hours later, a diesel train left traveling at 45 miles per hour in an effort to catch up. After traveling 4 hours, the train finally caught up. So here's the diesel train. It traveled the same distance. It traveled the same distance. So this is the cattle train, and this is the diesel train. It traveled the same distance, but let's talk about the time. How long was the cattle train driving before the diesel train left? How long was the cattle train on the road? Yeah, 14 hours. And then it says after 4 hours, the train finally caught up to each other, right? So what was the total trip that the total time that the cattle train was on the tracks? But the total time for the diesel train was 4 hours. Do we see that? Do you see how we discover that? Okay. It says that the diesel train was traveling at an average speed of 45 kilometers per hour. How do we figure out the cattle train's average speed? So again, they're both leaving from Miami to New York. So what do we know about their distances? So the distance is the same. So the cattle train looks like what? And the diesel train looks like what? Give me the R times T for both. What's the RT for the cattle train? Well, we know the time, but do we know the rate? We're trying to find the rate on the cattle train. So do we know it right now, or should we use the variable R? So the cattle train has a distance of 18 R. What about the diesel train? 4 times 45, right? So we said that these are the same. So I have 18R equals 4 times 45. That means 18R equals 180. Divide both sides by 18. And the cattle train is traveling at a rate of 10 kilometers per hour. 10 kilometers per hour. Okay. So I want to look at your homework. So I'm going to pull up the Canvas module really fast. Are you someone still writing that down, our notes? Are we done with that?